In this video, we'll be looking at population geography. Now, the increase in the human population in the last half century is unprecedented, and nearly all the growth is occurring in developing countries. In fact, currently 89.8 people are being added every year in developing countries worldwide, compared with about 1.1 million in developed countries. Now, while developing countries will keep growing, and some really quickly, the more developed countries may grow slowly or not at all. Now, the study of population is called demography, and it's important because there is a clear connection between population growth and virtually every challenge facing humanity. So things like famine, climate change, food production, traffic congestion, water, fossil fuels, access to family planning, all these factors interact with every aspect of our lives, regardless of where we live. Now, during the 20th century, the world's population grew at a rate never before experienced. In fact, at the end of the century, in the year 2000, there were 6 billion people. In mid 2018, there were 7.6 billion people. And currently in 2020, there are just under 7.8 billion people living on Earth. Now, by 2050, world population is projected to reach 9.8 billion. And this brings with it a bunch of challenges. If we look at this chart over here, and the population in millions, we can see that around about from 1700 to 1800, populations started going out. Now, this is a time that's basically between the start of the Industrial Revolution and moves up. The Black Death has been and gone. We've got typhoid and dysentery. Still not a great understanding of science. But after 1900, we start seeing it jump up after the world wars and explodes. And there's a reason for this. A lot of vaccines produced, health standards are better, people understand science more, and things are starting to change. Now, if we look over here to this table, the years taken to add each additional billion people, it is really interesting because in 1804, the world's population was 1 billion people, and it took all of humans' history, 2 million years for it to get that big. But interestingly, 123 years later, it jumps to 2, 33 years later, it jumps to 3, 14 years later, it jumps to 4, 13, 12, and 12 starts jumping up by the billions. Now, when will we reach 8 billion? Think back to what we just talked about before. Now, is this a problem? Lots of experts are concerned about the size of this increase, and they fear that the addition of another 3 billion people will degrade and even overwhelm the Earth's biophysical environment, the land's food producing capacity, and other natural resources on which all life depends. They're also concerned that meeting the energy needs of the growing population will simply accelerate the rate of climate change. And this will be especially be the case if alternatives to the burning of fossil fuels are not widely and quickly embraced. Others believe that the Earth's population should be seen as a valuable resource. They claim that technology will enable humans to cope with the problems that result from the increase in population. In saying all that, in 2017, the world's population was growing at an annual rate of 1.11%, and this was down from 1.13% in 2016. Annual growth reached its peak in the 60s, in 1960s when it was above 2%, but since then the rate of increase has almost halved. Now, the annual growth rate is declining. This doesn't mean that the world's population will fall. It actually means it will grow. It's just not growing as quickly. So when we look at things like population, like full logarithmic graphs and semi-logarithmic graphs are very, very useful. And we're going to be looking at a semi-logarithmic graph. Now, it's called a semi-logarithmic graph because only one of the axes has a logarithmic scale. So you'll notice that the x-axis, the one down here, it goes up in regular increments. We're talking centuries in this case, they're years. However, the y-axis, it's a little different. So it starts at 0 and it goes to 100. There are 10 increments. Each one represents 10 years. Then it goes, and people in population in millions. Next one goes to 1,000, next goes to 10, and each increment goes up by, in this case, thousands. And the next one, if we wanted to go further, would be increments of 10,000. We do this because it allows for data with a large range of values to fit on a chart. If we wanted to show this on a regular chart, what we would find is that this area here would be actually quite hard um, to show on the chart. So this lets us do it very quickly. Now it sounds scary, but it's not. It's, you read it just like any other chart. We're looking here at a population in millions. We're talking about 1,000 million. We're talking about 2,000 million, 3,000 million, 4,000 million, etc., etc., etc. So it's really not that difficult.